Hello, I'm Corey Beasley, and I am currently in Math 2000, a 2016 Challenge student, and I'm going to be explaining how to do problem number 92 on Chapter 4, Section 8. So, the problem is basically asking about the initial value. And this concept is used when you are integrating any type of problem. Now, we're taught that as we integrate something, well, the first rule of integration that I usually think of is, in order to integrate any value, you're going to increase the power by 1 and then divide by that power. So if you have the variable x, for example, and I'm just going to have f of x for the function, and you're trying to integrate f of x, what you're going to do is you're going to take the x, increase the power by 1, so you'll make it x squared, and then divide by the power that you just increased it to. So you basically increase and divide. And x squared divided by 2 is the integral of x. However, whenever you integrate something, you have to have a plus c at the end. Now, this plus c is very important, and it serves as a constant that you're going to have to add after you integrate something. And I'm going to explain how we get that constant and why that constant is a thing. So I'm going to sort of backtrack here. I'm going to explain derivatives. So if we were to take the derivative of f of x, and then f of x equals x, we're taught that what we're going to do is just basically drop the power by 1, or we're going to multiply by the power, and then decrease the power by 1. So the derivative of x is just 1. Now, if we say, for example, have the derivative of 4x plus 20, we're going to do the same thing. We're going to multiply by the power and then decrease the power by 1. So we multiply by 1, that just gives you 4. You take away the x. And then you multiply the power by 1 and you decrease the power. So you just basically take away the 20. So you're decreasing the power, but it already didn't have a power. So it's now going to go away. So now you just have 4. And that's the derivative of 4x plus 20. Now say after you found the derivative, you were to integrate the problem. So I'm going to go ahead and put an integral right here. So you integrate the 4. How do you integrate? You increase the power by 1, and then you divide by what the new power is. So that's 4x divided by 1. But we had a 20 right here at first, or initially. However, we're not going to know what that 20 is, because we can't just pull a constant out of nowhere. We have to have some type of indication of what the constant is going to be. So if I were just given x, and I was told to integrate the x, I could make it 4. However, I wouldn't know where I get the 20 from. That's why we have the value plus c. However, you can actually figure out what the c value is if you are given an equation, or if you were given a set of numbers, a set of coordinates. What you're going to basically do is you plug in the coordinates and then you solve for c with a little bit of algebra. So I'm going to go ahead and give the example that we were given in the book. Now that we have an idea of what initial value is, I'm going to go ahead and show you how you would find the initial value. So in the book, we're given the problem. We're told to find the integral of the derivative, or dx, of 10 minus x. So we go ahead and we find the integral of that. We integrate this. So we're going to increase the power by 1 and then divide by the increase. So we're basically going to take this and we're going to say the integral is equal to f of x equals 10x minus x squared divided by 2 plus c. Now, like I said, the plus c is important because we need to have that constant right there, but we don't exactly know what the constant is unless we get an ordered pair. And in this case, we're given an ordered pair. We're given the equation that y to the 0 equals -1. Now, this is very important because if we plug in 0 and -1 into this equation, we can figure out what c is through algebra. So the 0 is basically an x, and the -1 is basically a y. Now that we know what these two are, or I can just go ahead and write it out here. Xy, 0, -1. We can now plug this into this equation to solve for c. So let's go ahead and do so. So y, which is basically f of x, y equals f of x. We're now going to basically take -1 and then make that equal to 10 to the 0th power minus 0 squared divided by 2 plus c. So we have 10 to the 0 is basically just 0. So we can go ahead and make that 0. And then 0 squared divided by 2 is basically 0 also. So that can be 0 as well. And we have plus c. So we have negative 1 is equal to c. And that's going to essentially give you your constant. So your constant is negative 1. So if you were to replug this all back in, we can go ahead and say that this is negative 1. And then the constant we now know is negative 1. I'm going to put minus 1 right here. And the x is equal to 0. So we go ahead and put zeros for that. Again, these zeros are going to cancel that out. Make that become 0. Cancel this out, make that become 0. And you have negative 1 is equal to negative 1. So for a quick review, we're just saying that whenever you integrate something, integrate anything, any function, you're going to get the actual integration of what you had integrated. However, you're going to always have a plus c. And the plus c value, or the value of c, can never be found unless you're given an ordered pair, which we were in this case, an x and a y. The way you find the c is once you integrate the actual function, you're going to plug in for the x and for the y, and then you're going to solve for c. And as we did right here, we found out that c was negative 1. Thank you for watching the video. Again, my name is Corey Beasley. I'm a student at Challenge 2016, and I will see you in class. Thanks.